module 15. In this lecture video, let's take a look at how we can simplifying our radicals. So we spent a lot of time in the previous video talking about radical, especially talking about square and square root are opposite operation. They can cancel each other out. The different types of answers we can end up with, maybe an integer, maybe some sort of decimal because they are irrational numbers, and knowing that a negative can never be inside of an even root, but it can actually be inside of an odd root. All right, we spend a lot of time talk about that, so it can actually quickly help us simplifying our radicals. All right, I got two new rules right here on the side. Okay, now I'm going to explain, and then I will kind of use some of the same concept we explained last time. All right, let's say if A and B are positive, okay, they're always telling us it's positive because I always want to assume my answer is going to come out to be positive based on the principle of square root property last time. Because sometimes you can actually write negative in there too. They will still come out to be positive answer as well. So that's why the principal square root is kind of strange was introduced last time. So most of the time, most of these instructions will always want us to assume they are positive. All right, square root of AB. What that means is a square root of A times B. So A times B is only one term. So if I only got one term that's underneath my radical, what I can do is to split them into two separate radicals. Okay. In other words, if I ever do a multiplication of two radicals, I can actually put them all underneath as one of them. Same thing for division. Square roots or any radical of A over B can be rewritten as square root of A over square root of B because the A and B was initially under the same radical. Because it's one term, we can actually split them up as two separate radicals. We cannot do this if it's addition or subtraction because those are considered as multiple terms. We cannot split those, okay? We can split them if it's only one term. So the more factors I have inside my radical, the more radical I can split them up as. All right, very important concept. We do use this quite a bit when we talk about multiplication of radicals and division radicals. All right, the simplest form for square roots or any type of radicals is a square root or any type of radical is considered to be in the simplest form when the radicand has no perfect square or perfect cube or perfect fourth power as a factor. So what that means is when it comes to simplifying our radical expression, what we want to do is be able to break down our radicand. Okay, so there are a couple of ways we can do this. I like to show students a type of universal way that can deal with all types of radical. Even doesn't matter if it's square root, cube roots. Okay, so there are two techniques. One of them is simply look at your radicand. Okay, and break it down using prime numbers. All right, if I use a prime number, 2, okay, because what prime number can go into 24? 2 can and 3 can. 2 can go into 24 12 times. All right, 12 can actually be breaking apart using prime factorization by 2 or 3. I'm going to use 2 again. So 2 will go into 12 4 times. Oh, excuse me, 6 times, sorry. All right. So now let's break down the 6. 6 can be breaking up using prime number 2. 2 go into 6 3 times, and 3 is a prime number. Only 3 can go into 3 1 time. All right. So why do we write this prime factorization out this way? Because right now I can actually rewrite my square root of 24 as 2 to the third times 3. Okay, but since I'm dealing with a square root, what I can do is write my 24 by the prime number as 2 squared times 2 times 3. So I'm just going to do this one time, okay? Then I will begin to write out differently. So because this is multiplication, I'm only have one term. So I can begin to split it up, split the 2 square, okay, away from the other 2 and the 3. So square and square root canceled out. Only thing I got here is a 2 times, well, this 2 and this 3 together within the square root is going to be a 6. So my answer is actually 2 times square root of 6. Okay, so this seems like a lot of work, which is because once you see this one time, you can basically say, well, if I'm dealing with a square root, that means I need 2 of the same number to go outside as one of them, because the square and the square root can cancel each other out. So I have 1 2 left and 1 3 left inside the square root, so they got to stay inside. In order to go outside the square root, you need 2 of the same number to go outside as one of them. So that means everybody else got to stay inside the square root. Okay, so that's one way to do it. Another way we can do the same problem is basically figure out a perfect square number that can go into 24. So for small number, it's not a big deal. For a number that's kind of big, it tend to get a little bit, it tends to take a little bit more time to figure it out. Most of us know 24 is 4 times 6. So square root of 24 written as 4 times 6, then I can kind of split them up to be square root of 4 times square root of 6, which square root of 4 is going to be 2 anyway. And square root of 6 is not a perfect square, so we'll just simply write square root of 6. So the answer is still going to be 2 times square root of 6. So a lot of times when students see this one time also, they will just begin to say, okay, I'm just going to write my 4 and the 6 underneath here. Square root of 4 is 2, and the 6 is not perfect square. It got to stay inside. You can do it that way. Okay? So again, for small number, looking for a perfect square number is not a bad idea. For a large number, it gets a little bit tougher. Alrighty, let's take a look at this 12. Okay, this negative sign of outside this radical will still keep my answer negative. So for 12, okay, I'm gonna just show you this again. I'm gonna break it down using my prime number, using a 2 going to 12 6 times, 2 going to 6 3 times, 3 going to 3 1 time. So what I'm looking for is 2 of the same number to go outside as 1, since I'm dealing with a square root. So these two 2's will basically go outside of my square root as 1 2. So since this is only 1 3 here, it cannot go outside because I need 2 of the same number to go outside. So the 3 will remain inside the square root. Okay. So what do I mean by inside, outside? Because technically the 2 times 2 times 3 is actually all inside the radical. It takes 2 to go outside because these two 2's together become 2 squared. So square and square root canceled out. This 2 will actually be outside. This 3 got to stay in the inside. So all these got something to do with what I'm explaining up here in order to split the radicals apart. So to keep things easy, I normally just kind of look at them here on the side to determine who can go outside, who will have to stay inside. All right, sometimes that makes it a little bit easier. So there's 2 ways now, okay? To simplifying radical, okay, we can say square and square root will cancel out, or we can just look at them and say, well, it takes 2 of the same number to go outside as 1, so that means everybody else can stay inside. Okay, it's basically saying the same thing, just write it out differently. Alrighty, now let's do this problem. Okay, if you put this problem in the calculator, it's simply just going to be some sort of irrational number with a bunch of decimals. So we really can't do too much with those. All right, so for this problem, what I'm going to do is to split them. Oh, what did I do? Let me erase that. For this problem, I'm actually going to split this into two separate radicals initially. What's confusing about module 15 is there's a lot of different ways to do the same problem, okay? There's a lot of different ways, so that's what's confusing about it. Just be careful, be careful. All right, the reason why I'm splitting this up so we can quickly see that square root of 25 is going to be 5. Now, the 120 up top is not a perfect square number, so let's break this down. So just gotta be careful. If you want to search for a perfect square number that can go into it, you will say, oh, 4 is a perfect square number because it's 2 squared. But then you might need to continue to try to break down the 30 and say, well, 30 is also divisible by 4. Oh, no, not divisible by 4. So 30, who can go into 30? Perfect square number. 6, no. What was that? 4, you can see I'm not good at this because I normally don't use this technique. 4, after 4 is going to be 9. 9 cannot go into 30. Then after 9 is 4 squared is 16. So on and so forth. I don't think anybody can actually go into 30. None of the perfect square number can go to 30. Okay, so the answer is probably going to be 2 times square root of 30. I don't know. So what I'm going to do is kind of do it from a different perspective. I'm just going to simply break down my 120 using prime number only. 2 go into 120 60 times. 2 go into 60 30 times. 2 go into 30 15 times. 3 go into 15 5 times. Well, 5 is a prime number, only 5 can go into 5 1 time. So that's where I'm ending. So what am I looking for here on the side? What I'm looking for here on the side is 2 of the same number to go outside as one of them because I'm dealing with the square root. So these two 2's will go outside as 1. So I got a 2 on the outside. So now I have 1 2 left, 1 3 left, and 1 5 left inside the square root. So if we multiply them together, which is right here, right? Because after I pick the two 2's, then it's 30, the 4 going to 120 4 times. So this 30 being broken apart into 1 2 1 3 1 5. Since I only got 1 of each, so that means nobody can go outside. So when they stay inside, let me write it right below here. They become 2 times 3 times 5, which is still going to be that same 30. There you go. So my answer is 2 times square root of 30 over 5. All right. So you can see, I struggle with perfect square numbers already, and I teach math. So imagine perfect cube numbers, okay? That's a lot of thinking going on for a number that is a little bit larger. That's not easy to pick up on. So let me do this one right here. So I'm just going to break this thing down. Remember now, this problem, I'm dealing with a cube root, okay? So I will be looking for 3 of the same number. I know prime number 2 can go into 192. So a lot of times, when we do this, it's really interesting. If I just use a 2 go into it, that's 96. Well, 96 ain't perfect square number. Let's keep on breaking it down. 2 go into 96 about 48 times. Let's make sure. All right, break it down by another prime number 2 again. So 2 go into 48 24 times. Use 2 again, that would be 12. Using 2 again, that would be 6. Using 2 again, that would be 3. 3 is a prime number, only 3 can go into 3 1 time. Okay, so we are not using perfect square numbers because this is a cube root. So I'm looking for 3 of the same numbers. So these 3 2's will go outside as one of them. Again, these 3 2's will go outside as one of them. Okay, these 3 is only by itself, so it got to stay inside the cube root. And please don't forget to enter the cube roots on the homework. So on the outside, 2 times 2 is 4. So my final answer is 4 times cube root of 3. Okay, so if you ask, well, what perfect cube number can go into 192? Well, the first cube number is 1 to the third, which we don't use. 1 going to anything is 192. All right, 2 to the third is going to be 8. 3, so can 8 go into 192? Yes, it does. Going as 24. So if you say, so what happened if you say, okay, this is actually cube root of 8 times 24, and cube root of 8 is going to be 2. So that's 2 times cube root of 24. That will actually be a wrong answer, because within the 24, there's actually another 8 inside of it. Okay, so a lot of times student would just keep on going. Maybe 3 to the third power, which is 27. Okay, it turns out we actually need 4 to the third power, because my answer here is 4. It's kind of obvious. So that will be 192 divided by 64, which is 3. So that means this 3 got to stay inside. Cube root of 64 is actually 4. So you can do it this way if you like, or you can simply just break them down, okay, especially for a number you don't quite recognize. All right, that will conclude this lecture video on how to simplifying our radicals. 2 basic technique, okay, looking for perfect square or perfect root, perfect cube problems, depends on the radical, or we can simply break it down. Either way, when you break it down, looking for how many of the same number to go outside the square root or cube root is basically just another way of saying square and square root can cancel each other out. Okay, it's basically saying the same thing, just written out differently. All right, that will conclude this lecture video. Thank you for watching.